Hello and welcome to a new video on our channel. Today I have an interesting guest, and let me start by telling a story about this. A few years back we were organizing ITACAN conference, and we received one paper that I didn't fully understand, basically. I had to search it, and because I don't remember the name. It was called Aesthetics and Narrative, Programming That Cannot Be Programmed. It was one of those papers that I read. I couldn't understand a lot about what was supposed to be in the talk, but the topic was very interesting. So we did the only thing that we could have done for a conference like ITACAN conference and turned it into a keynote. And the person who submitted that is here with me today, David Schmüdde. Hi, David.
Hi.
So usually I know how this conversation will go because we kind of know the topics that we will discuss and things like this. Today I have no idea. I just have a few things as topics that we can start and have a conversation on, and then we'll see where this takes us. So
great.
First of all, it's interesting to start with a quick introduction for you because you have a unique background. You are a programmer, but also an artist. And can you tell us more about this?
About this terrible life decision? Sure. Yeah, so I have a background in computer science, a degree from Northern Iowa, university there. And then I went on to get a master's in music from Northwestern. And after that, I worked in the media industry for about 10 years. And I was quite interested in the intersection of storytelling and new modalities of storytelling. And so, of course, you come up with a paper at some point like Aesthetics and Narrative, Programming What Can't Be Programmed, because, of course, I am interested. I have a background, although it's getting to the point where so much has changed in artificial intelligence. It's hard to talk about my background because most of that was in expert systems a while back and not in hot machine learning. But I have a background, a formal education with artificial intelligence where, of course, I was interested in applying that to the arts and whatnot. But this was the late 90s, early 2000s now. So it's been quite a while. But anyway, I ended up then working in this capacity in New York and in Berlin and Chicago. The last endeavor in Berlin was working with a company called Next Journal, where I worked on computational notebooks dealing with the reproducibility crisis in science, where we're trying to make sure that scientists can show their work, document their work, and reproduce the results and share them with one another and publish them in runnable code everywhere. So you can really see the intersection between narrative and storytelling and code right there, all embodied in a computational notebook.
Yeah. So I remember you are doing some kind of artistic installations using programming and AI and all kind of things. Can you tell me more about some of these projects?
Yeah, I mean, the last residency that I had, that was not so much AI-based, but I was working with an artist in New York named Kim Burgess, and hopefully someday we can pick up this work again, but we're interested in body and movement and sort of the implicit language shared between people physically as they move through spaces. Maybe think about how you move through a subway platform and you navigate and communicate with people without even consciously thinking about it. And we were sort of measuring or I guess viewing people with an Xbox Connect as they moved into spaces, and depending on how close they were, or how they were moving, or how many people were in the space, we would change the ambient conditions in the space. Sensorial, and then we had some static, sort of like non-interactive, I should say, video components to it. And all that was done in Clojure, because I have a background in Lisp and kind of still love the parentheses to this day. So Clojure is still my language of choice.
I remember you had an interesting use for tests in that case. When you are generating, or at least for the talk you gave at ITechCon conference, you're generating music, I think, and you use tests as a limitation for the sounds. Do I remember correctly?
Yeah. So, I mean, this is a Clojure specific sort of, I mean, it's not Clojure specific, this concept, but the tooling I was using is a library in Clojure called Spec, and basically Cognitech specification library that is used to generate tests or put constraints on functions and whatnot as they are written. And so, I mean, what I needed to know when I was making this art piece, of course, is I need to battle test the system just like anybody else does, because you set up this system in a gallery and then you walk away, and I hope it works. And if it doesn't work, I hope someone tells me that it's not working. I mean, the gallerist maybe doesn't even know so much about the technical specification or how it's supposed to work. I mean, it's not their full-time job to know about interactive media. So you really want to make this stuff as bulletproof as possible. So you do some heavy generative tests to make sure that the synthesis engine that I was working with and sort of the fire hose of data that's coming off the Xbox Connect, that sort of stuff doesn't overload the system in some unpredictable way and create problems for you. That, I mean, how do you test for people in a room? I mean, it's very difficult to test this concept without getting warm bodies in the room. And there's only so many times I can ask friends for favors. So I was using Spec for this purpose. And at the time, this is a pretty new library, and Cognitech, actually, I'm not even positive Cognitech has taken it into out of alpha yet, which is kind of amazing. I think the API is still not completely stable. And so at the time, though, they were trying to get sort of like people to adopt it and bang on it. And so I talked about it at your conference, also at the Cognitech Conj, the major Clojure conference that happens every year. So I talked about it in Austin. And there was some interest that at the time in using tests for like aesthetic or bizarro ends,
Yeah, I found that an interesting idea, because we usually try to teach people to write tests in order to check that the expected behaviors are correct. But in your case, it was also kind of constraint on the system, as you put it. And
yeah, specifically in this case, function signatures would be, your memory is very good. Function signatures, of course, can, because you're passing functions around, or you're passing, because you're in functional programming land, right? You're just passing data around. Yeah. And so, this data can be, especially in Clojure where it's not typed data. I mean, you can bring in a type library, but it's not that kind of language. And so this is what Spec is supposed to kind of make up for, right? It's supposed to have a way to formally specify, of course, kind of what you're looking for. Experiment with the specifications in the artistic case, experiment with the specifications, and then change the code, actually, depending on the aesthetic results. But use the specifications to generate all sorts of situations that you wouldn't have thought of necessarily, or couldn't test by yourself without, again, actors or physical or friends in the room kind of working with you and directing them. And it's kind of an untenable proposition over a period of time.
Okay, so about functional programming, I know you are, and you already mentioned you are very keen on using functional programming. You like it. Now, my experience when learning functional programming has been that I loved to write code, and I went to the university at a functional programming course, which was mandatory in my case. So, and I went through it, and our teacher was very passionate. He loved this domain, but I couldn't understand the thing he was telling us. It was very, very difficult because I guess years later it was because it was very linked with mathematics and the fundamentals in mathematics, and I basically wanted to write code. It wasn't and I think after sharing this experience with other people, many programmers tell me that's kind of the same experience I had. So it would be interesting to hear from you what made you love functional programming.
Asking you two questions first. I'm curious about your experience. One, I'm curious about the language that you used, and two, in college, and two, if you had a lot of programming experience before you came to that class.
So I had a programming experience in C++ back then, and Turbo Pascal and BASIC, and ZX80 assembler, if that counts.
Oh yeah, absolutely.
Yeah, but as you can see, my background was specifically in imperative programming. All of these were imperative things. And the second, it was Lisp and what's it called? The old variant of Clojure, I think. Kind of an
Scheme.
Yeah, Scheme.
Scheme.
Yeah.
So I just took this class in Chicago with David Beasley, who was a professor at University of Chicago. Now he does independent classes in the city. He's not associated with the university anymore. Not to make this an advertisement for that. This is about a month ago, and I'm still super excited about this class. But he taught, in 5 days, he taught a SIPI course, Structure and Interpretation of Computer Programs, course on the Wizard book. Yes, this beautiful book. I love this book.
Yeah.
Right. And anyway, I thought he did a fantastic job teaching it. But one of the things that he did so well was admit that this book is gonzo and it's completely difficult to he made me so comfortable, because you read a book like this and you think, oh my God, I'm on page 10 and this is already hard. Like, when does the easy stuff come? And you literally don't set a variable in this book until like page 200.
I remember,
right?
Yes.
Yeah, I mean, this is crazy. And you're coming, I can imagine you coming at this, like, already hacking on Pascal and assembler and whatever, and getting stuff done. And like, you go 200 pages without even setting a variable. And how many times can I write Fibonacci, right? In how many different ways? So I understand, sort of this frustration when people come to it when they're young. And then also, I taught a class at Stevens Institute of Technology. That was the last place I was teaching. And I was teaching an ethics class, Computers in Society. And it was a required class by all the computer science students at the university. They all had to take it. And they all had to take a sort of like the class you're describing, an FP course, a Scheme. I think it was Scheme course. I don't think it was SIGP, but I surveyed it didn't really have anything to do with the class, but I was totally curious. I surveyed every single time I taught that class, and I taught it probably 7 or 8 times in the course of 2 years, maybe 9 or 10. And I always surveyed, and I said, okay, who's taking this class already? And, 3/4 of the class would have raised their hand. And we said, okay, so who liked this class? Maybe one person, maybe. Okay. Who is indifferent in this? Who didn't? Who's kind of indifferent? Like kind of liked it, kind of different, and maybe a couple people who didn't like it. And like of those participants, most people would say, "Oh, I didn't like this class," and da da da. And I'm very curious about how to teach this to people in a way that is engaging, the way that it shares sort of my love. Now, to get to your point, your actual question. So for me, it was sort of love at first sight, because I think one of the things that's happening here is scheme and SIGP are great equalizers, meaning that you had a lot of experience before coming in, right? But there was probably half of your classmates had never programmed before. They had heard about it, or maybe. I mean, I don't know your school, but
No,
there's a lot of.
Everybody had programming experience.
Everybody had.
Yeah.
Okay. So, but in freshman college, so like where I went to school, the freshmen, like some people came into class and they didn't have any programming experience. This is their first time really doing some real programming. And SIGP is a great equalizer because nobody has done Scheme or Lisp, right? And I had never heard of it either. I went into college like you. I had done some Pascal. I had taken some C++ course that totally, C++ that totally kicked my butt. Basic. Those are kind of my languages. And I got into university and we did ADA, was where we started. And then we did some Java, of course, and did some Prolog eventually. But then I got into this artificial intelligence track and we did Lisp. And it was love at first sight. I was like, oh my God, this makes sense to me. This is so much more sensible, because so many of my choices, and this is one of my favorite things about functional programming, especially on the REPL. And I don't know so much about ML style languages as much, but on the REPL with a Lisp, you hack and build, and you defer the big architecture decisions. You keep deferring them till later. And it made so much more sense to me than OOP, where like I'm making big architecture decisions up front. I'm saying, let's take the ball example that you all start with OOP. You have a ball, right? What properties does the ball have? I don't know. What properties do I need to know? Do I need to know its color? Because it always has a color. Maybe I don't need to have a ball color, right? But I'm assuming that at the beginning. I'm assuming all of these things about this object I know nothing about. The client just asked me 2 weeks ago for this ball, right? And we had a backlog. It's coming up it's coming up this week. Okay, we have a scrum. Okay, we got to implement the ball. Okay, what do we know about the ball? Well, the client thinks they want this. Well, the client thinks they want, but it doesn't fit into the thing. And we have to make all these decisions before I start coding. And this was the opposite in my experience in REPL-driven development in Lisp, where I didn't know so much, or I don't know so much whenever I start programming. So I'm just building functions and then composing them and putting them together. And it feels so much more like Legos, and it feels more tactile to me.
Yeah, I can definitely understand that. I wrote a book on functional programming in C++ that was published last year. And basically what I wanted to do was to talk to these people who are like me, who knew some programming language, who went through maybe a course, learned about functional programming, but couldn't understand what
awesome.
is interesting about it. And it ended up also being very fun playing around with functions and composing functions and building things out of very small bricks. It's a really cool way of writing code. But my feeling is that some of the challenge comes from a different way of thinking. The way I learned to write functional programming in the end was by switching my mindset from behavior to data in, data out, and transforming the input data into output data. And that gave me at least a gateway into how to write functions and pure functions and so on.
I'm really curious. I mean, I saw when your book came out, and I was pretty curious about it. I'm not going to be doing any C++. If I'm lucky, I'm not going to be doing any C++ anytime soon. So I haven't picked it up and taken a look at like how you start. But I'm curious with C++ and your approach. Are you working? I mean, without homoiconicity, without like being able to evaluate your own syntax as just raw data. I mean, you still do have a lot of upfront sort of like typing decisions to do, or like you're still deciding what your data is shaped like quite a bit, right, at the very beginning, and then you're compiling, and then you're modifying, or how does that workflow kind of look in your book as I'm building out a world for the first time in C++?
So it's different from REPL. That's definitely is different. I replace that with test-driven development usually when I write code, and that helps me kind of build step by step what I need. But in terms of types and things like this, what's very interesting now is that C++ has reached a place where it has autotypes, it has lambdas. You can relatively simply do currying and functional composition and all these things, and partial application. The syntax is a bit weird at times, and basically that's what I try to explain as simply as possible in the book. But most of the book is about the concepts and how you combine things and build stuff in this manner. So yeah, you can actually do a lot in C++, but not REPL. It will be a different kind of development style.
And I don't know if you have much Python experience, but their lambdas are awfully hard for me to read, like the syntax I'm just talking about. And there's some limitation as far as I've kind of run into with what you can return the lambdas. I mean, I don't know if you can compare the two, but does C++ have more flexibility with their anonymous functions and whatnot than, say, something like Python? Is it is everything first class? Every type, everything's first class, or is it?
That depends. So actually, when you're writing a lambda in C++, the compiler automatically translates it into a class, because that's what C++ knows by default. But it's also one interesting thing about C++ is that it has a ton of optimizations. So basically, even if it translates it into a class, afterwards it can optimize it and so on, so that it's not quite heavy on the memory and all that stuff. But in terms of writing the code, the syntax is a bit weird. I can tell you that. And you still cannot do everything as easy as I can in Groovy, for example. So for me, Groovy is kind of the best way of writing lambdas, the simplest way of combining functions. There's actually a functional composition operator. What else do you want?
We're getting really into FP land if there's an operator.
You can do currying just very, very easily in Groovy and so on. So, but yeah, that's, to me, that would be the simplest programming language that I know now,
Yeah.
where I can use basically lambdas. Okay, so that's functional programming. Let's switch gears for a bit. I find it very interesting in your, and I think that's something, this is something that we share. We both have a kind of humanistic side and a technical side. I used to write, and actually that's why I'm also writing books now. I'm writing for probably 30 years now, things continuously. And when I decided to go to a technical education in high school, everybody was confused that I didn't pick humanistic education. So, and now what I find is very interesting that in this tech world, programmers tend to be very technically oriented, whereas much of the work is actually also humanistic in nature.
Yeah.
So I was wondering if you have any, I don't know, things that you noticed with programmers in relation to that.
Well, and I mean, one of the things that I've had the luxury of is working with young programmers, of course, because I've taught college for a number of years. Not always programming, actually very rarely programming, mostly on the humanities side of things. I have taught a few technical, like purely technical classes. I will say one thing is, at least at Stevens, and Stevens is not a liberal arts university. So in the United States, of course, you have vocational schools where you learn a craft like programming or auto repair or something like that. And of course, then you have technical universities that still deliver, you still get a bachelor's or whatever at the end. And then you have liberal arts, right? Universities that are more interested in theory, with the well-rounded education. And I was a little concerned when I went to Stevens Institute of Technology, because I thought, oh, these kids are not going to be very receptive to my classes. Like, my classes are going to be the pain in their butt, right? They're going to be really good programmers or something like that, and they have to take these awful, even though, so I taught cyberspace and national security there, and I taught computers and society. So even though, like, it's in their wheelhouse, I thought this is gonna be really hard to engage these students. And honestly, they weren't any more difficult necessarily than my liberal arts students, and they were different. I mean, in the sense that they were a bit more system oriented and structured, right? They really appreciated structure. And so you have people that are systems thinkers, right? They're coming at this as people that enjoy building out systems and whatnot. And this is kind of why they're good at what they're doing when they're young. And maybe it's like how we treat the arts in general, where when you're in a class with a bunch of young kids, I mean like 6-year-olds or 7-year-olds, and you ask, who here is an artist? Like half the class or more, all these little kids are going to raise their hand because they can draw, they can do all these things, and they love doing it. Do that in high school or as an adult. As adults, get a room of people, who here is an artist? You'd be lucky to get one person to raise their hand. So what happened between here and here, right? And it's also, I think, within computer science, one of the things about Sussman's work, for example, SIGP, or some of the better educators in CS, is they think they never lose track of the fact that you are building systems, right? And you're not like you might be really clever with your one-liner or really clever with this small little section of code or whatever, um, but the true accelerate, the truly great student, is really good at thinking systematically and understanding how to design sort of like an object system or a type system that is robust and can actually be extended down, 3 years down the line, which is the hardest thing, right? Like,
Yeah.
3 years down the line, you have no idea what's going to be happening here. And so I think that's one of the things we might beat out of these students, or we don't emphasize enough, because it's incredibly abstract systems, right? And not only are systems incredibly abstract, but they're also what we experience every single day, right? Like, I'm currently living in Italy, and of course, like, the difference between the German system, the American system, and the Italian system. I mean, every time I've moved, now I've moved to the third country, it's always incredibly difficult to understand the nuances of the system that is how humans work, how everybody works, and everybody complains about it, and everybody thinks about it. And so, and nobody wants to be just an anonymous person in the system. Everybody wants to participate in a meaningful way. And so there is, within the core of computer science, there is this like deeply humanistic problem where it's like, we like the systems that we have. We like, for example, that we have a police department and a fire department, and we have some sort of like amenities that are paid for by tax dollars, right? We all wish it worked better, right? But their core, we all understand that that's core to our experience and our civilization as we know it. So that is like one core issue that I think is, I wish was more part of computer science as like, or informatics as like thinking. And then there's this other part where I'm not sure what it's like in Romania, but in the United States, of course, we have had this great emphasis since the Cold War on STEM education, science and technology, engineering and math. And this I find deeply problematic, and I don't want to get onto a digression about that, but I think it's starting to demonstrate how problematic it is as tech companies have more and more power, but seem more and more unable to deal with human beings, right?
Yes.
And with dignity. And I think a lot of that comes from just a lack of humanities concerns, like a lack of preoccupation with humanities. I mean, the reason nobody remembers Steve Jobs because, of course, they thought, oh, what a benevolent and nice person. He has a terrible reputation.
Yes. But
he was so exceptional, not because he was a great artist or something like that necessarily, but because he just cared. That was so unusual to have someone with that sort of power and technology that just cared a little bit about this, right? And so obviously, I personally believe this is something that we need to find a way to make critical as part of technology education and technology itself.
Yeah, so I find it interesting that I posted a few tweets, I think it was last week, and one of them was that programming is a profoundly humanistic activity in reality. And I got very weird responses, things like, yeah, but if you only know communication and so on, you won't know how to solve problems in programming. Well, of course, you need to know technical things. That's obvious. But we also need to take into account that today we are not writing code for the computer, because the computer understands us now. this has been a problem like maybe 40, 50 years ago when you were writing code that was limited by the technology that you were using. You could only write very short names or there were many limitations. But today we can write basically anything we want in code and the computer will understand it. And so what we are doing is we are writing code for the people who come after us and read it and try to understand it and to change it and so on. And this to me is a profoundly, again, humanistic perspective. You are writing code for people, not for the computer. And also to add to this, why are you building software? It's again usually for people. It's not somebody needs that or somebody could use that to make a task faster or easier or but these kinds of things, I find it very strange that I need to explain them like step by step to programmers.
Well, I think we have been very lucky as programmers to have the institutions be so hands-off of our work. And the thing is, either we're going to care about this or the politicians and the lawyers are going to get involved and they're going to change it, you know? And what I mean by that specifically is, I'm getting my hair cut in Berlin. I'm talking to the person cutting my hair. And she's telling me, she went through 4 years of school to get the certification. But she's not going to go, she is not going to go to another year of apprenticeship so she can then open her own salon. That's what she kind of wanted to do, but she just found it so absurd after all of this schooling that she needed another certificate, And I'm sitting here thinking, okay, I mean, I could get hired to work on a weapons system like tomorrow. Yeah. And I don't need any certification I don't even need a degree. I don't need anything to say that I'm prepared to work on this, which I like, actually. I'm very happy about that situation. So I'm not actually arguing for more certification, but if we don't self-govern and we don't start caring about like making people outside of our domain a top priority, then things are going to change, and they'll definitely change when the lawyers get involved, when somebody has to be held accountable for the loss of $3 billion. Let's say someone loses a lot of money and they want their money back, and it's due to some kind of error, right? I mean, people have died because of programming errors, but in terms of like real financial losses, real problems because of programming errors, things that affect very powerful people, this has not been our problem so far as programmers. And if someone does need to prove that that a certain line of code or a certain programmer should be held accountable for the software that they make, if this becomes a part of our vocation, it's going to change the possibilities of what we can accomplish. So we really need to make this front and center.
Yeah, and I like what you said about thinking about programming as a system, because it involves users, it involves many other things around your code. It's not just your code. And I also enjoy the freedom of being able to write code without a license.
Yeah, absolutely.
That's great. But it also, we need to understand, I think, the responsibility that comes with it. It's right. So again, to switch gears, we mentioned AI a bit previously, but I remember you were talking at Titancam conference about AI as augmented intelligence rather than just, let's say, a competition for people. Yeah. More like.
Yeah.
So have your views changed since then, evolved, given the new things happening in AI?
Yeah. Well, I mean, I think I've noticed more activity in the domains that I'm thinking about than 10 years ago. So I feel more validated. And this was what I'm talking about. So of course, augmented intelligence is not something I coined.
Yeah.
It's Douglas Engelbart, working at the Stanford Research Institute um, in the mid 20th century. And of course, he's most famous for, of course, the mother of all demos, which demonstrate the mouse and windowing environments and all that, right? And and the original usage of that term, of course, is to have computers sort of at our call to augment our natural intelligence and natural abilities. And this is the great future that he sort of envisioned, for those who are unfamiliar with this term that might be watching. And I've actually seen. I wish I could name drop right now, but there are there are some really interesting. There are some interesting people working on these concepts of augmented intelligence. They're mostly people in the domain of the future of programming. People that are investigating other ways to enable people to be expressive that aren't necessarily syntax geeks, like you and I might be. Um, and there's some really exciting ideas floating around. And the thing about it is like, you said this thing earlier about the limitations are such that these days people can sit down and they can kind of do what they want without worrying about what the machine is capable of, right? And we're getting to the point with cloud, of course, where you could even just, if you didn't have enough resource, you can rent more,
Yeah.
download more RAM. That's a good website, by the way. Download more RAM. It's really a funny one.
That's cool.
Anyway, so the work in this area is really interesting, and I'm hoping that it'll continue to gain sort of more cachet in terms of like research and interest, because of course machine learning is the domain of great investments and research interest right now, where the results are, of course, AlphaGo is, of course, an astonishing achievement. I mean, there's no denying sort of what's happened in machine learning the last 10 years. And I think there are limitations to with this black box approach, but you can't take anything away from just, it's been astonishing. And I think that augmented intelligence is something that is more, to your point earlier, also is more of a cultural thing. It has to be where people start seeing and feeling more expressive, more empowered by their devices so it's not a short leap, like the mother of all demos was a leap, or a short leap like AlphaGo is a leap. These leaps where people are amazed by what the computer can do. They're smaller victories that I think add up, where, for example, the things that went into the iPhone, the computer in your pocket, there were plenty of computers in your pocket before the iPhone, right? Yeah. And it just took a lot of small things to change before that product could come to life. And even that product for me has been, well, I guess the tablet has been kind of uninspiring to me, because we're still not at the point that Alan Kay envisioned, 70 years ago, where for me, most of what's happening on the tablet, there are some exceptions, some great apps that are exceptions, but for the most part, the tablet is a consumption device and not an expression device, a way for me to build my own tooling and easily build my own tooling, just based on what I was creatively thinking, as easy as I could use a pen and paper, and or work with wood or whatever. So the augmented intelligence paradigm has to see those sorts of tooling come together, and then maybe there could be a big time product that comes out of that. But at the very least, these small gains are kind of, I think, where it's at for the foreseeable, for the near future. We're still in the small game sort of thing where really adventurous people are mining ideas in the past that were impossible to do at Xerox PARC because the hardware wasn't there, or were impossible to do at SRI because the hardware wasn't there. Even like, for example, and then this is where I'll stop sort of this ramble, but even, for example, immutability in programming. Like immutability is not a new concept, but changes in hardware and changes in algorithmic research, new efficiencies found within how we structure or write algorithms, have made immutability something that's possible. And I think that's a huge game changer too.
So you mean in hardware, you can make immutability possible, or?
Yeah, I kind of leaped. Sorry, there. I kind of leaped between two things. One, augmented intelligence, small victories, to hopefully eventually make a big time product. And what I was also saying, but a lot of these ideas that people are mining from come from the 70s, come from the 60s. When the computational resources weren't there. The same can be said about programming languages and programming concepts like immutability, right? Which really wasn't possible in hardware, but it also was because of continued algorithmic research into continued research into data structures, I guess is more accurate, to create the underlying tree structure that can make this possible, branching structure.
So you would expect more of an incremental development on augmented intelligence, to the point where we get to be more expressive, or something like that.
I think we're
to bring more ideas together.
I think we're still not there. And I'll say something really quick that kind of is my threshold. And I think so Alan Kay, when he published about the Dynabook, sort of what he imagined was two kids having a Dynabook, which are essentially tablets, in the 1970s.
Yes.
That's what he's envisioning. And they were able to make games on the Dynabook and play games with each other, games that they made, not video games that were programmed for them that they're ingesting. And he was basing this on the idea of, kids on the playground make games all the time. They make them up constantly. They constantly are inventing. And so we want to create a software system that allows kids to do that. And that's my threshold. When kids can make games and have fun making stuff, this is a leap.
Yeah, I see. Indeed, it would be a very interesting world, one where people could easier create things based on software that exists and that understands them better than,
Yeah.
And I think this is related to, this is strangely related to something that I noticed by building our own product. We noticed for the first time, since I wasn't in the position of a programmer anymore, I also knew how the budget was structured and things like this. And I realized how expensive it is to build custom code. It is hugely expensive, and not only to build, but then you deploy it, and some OS update comes and it just breaks.
Yeah.
And it's an unbelievable world to me that this is still happening. That you still cannot write kind of a piece of software, even if it's properly tested and so on, deploy it and it will work, and it will work for a longer period of time. And so starting from this, I started experimenting with kind of combining pre-built components, so no code, just trying to combine things.
I see.
And I ended up doing much more, solving much more problems in this way and faster and so on.
Yeah.
So it's quite interesting that this also relates to, I think it was Brad Victor who had a really cool talk about feedback and how his worldview is that programmers should basically build tools for other people to express themselves. And that's something that's very interesting, because if you have these kind of tools, maybe we don't need as much programming. What we need is to design systems that can actually work together and be combined.
And what was the outcome of this combining, this integrated thing that you were building? Did you? Because you're integrating systems essentially.
Yes,
right?
Yes. Yeah. I have a few things I can share now, because all of them are Mozaic Works infrastructure, basically. So, for example, we standardize on WordPress. We have many websites that run WordPress. Now, I don't like, if I look at the WordPress code, I hate it. Right?
Yeah.
I cannot stand it. I wouldn't go near it. However, I don't know exactly how they are doing, but it works. And combined with plugins, combined with some kind of integration technologies that I'm still working to standardize. I tried Zapier, but I will also try a few others, because I need to pick one. It's interesting to see how you can build things that work, that get integrated, that communicate to one another without having to write a lot of code. And actually just we are paying for premium plugins or premium themes or things like this to have support, a right infrastructure for deploying WordPress so that we know it works and so on, and it has backups and all these things. But once you have that, actually the costs are I would say probably at least 10% lower than building this thing yourself. And maintaining it, because building is one, but then you also have to maintain it in time.
And you have the advantage of experts then, or people that really care about blogging, for example, working on that. And you might want to make a blogging tool, but it probably won't be your life's work, and there are some people on that team that have been working on this problem for 10 years or more, who knows, but you're leveraging all of that experience when you don't work on your own custom stuff. You open yourself up, of course, to security problems and things like that when you don't roll your own. But then there are all sorts of problems with rolling your own on security as well. So, I mean, I think this integrated solution, of course, is quite old, but what we want, I think, is we still want a world where things can talk to each other in rational ways, that we can just be one part of an ecosystem and rationally communicate with other machines on this ecosystem, which is the whole idea since small talk before, So, and it's quite astonishing actually how far we are from this concept in detail. I will say though too, part of the problem I think in realizing this future is solved also with immutability, because I mean, if you run code and an update breaks your code, right? Well, I mean, if you version the entire stack, right? This is something we were working on in Next Journal. Then you have the advantage of a guarantee that as long as a container can be run, as long as, for example, if you version the data every time that you change data, because as Rich Hickey claims from Clojure, if you change a thing, and this is a perspective you get when you think about immutability everywhere. If you change a thing, it's a new thing. There's an argument, of course, that when you're dealing with objects, if you change the teapot, it doesn't make it a new teapot. If you change the state, for example, of my phone, I don't make a new phone, right? And so when you think about it from an object perspective, if I change the state on the phone, it's still the same phone. That's the object perspective, right? But in immutability, if you change a thing, it's a new thing. And because these aren't actually objects, they're pretend objects that we just made up to make it easy for us. But in reality, every time in an immutable world, every time you change a thing, it's got a new state, it's a new thing, and you name it something new, or you give it a new way to access it. So what that means then, of course, is your old thing always works. And I think that in a world of small talk communication sort of infrastructure where these machines are always able to talk to each other, if a machine is immutable, right, as like Ted Nelson's sort of like original idea of Project Xanadu, if this thing is immutable, then if someone else changes the machine, you can still have a conversation that you expect to have, right? And so immutability, this is one of the reasons I think immutability is such a game changer, and we're just at the beginning of this, because for the first time we have practical immutability, like closure, like blockchain, and we don't know exactly where this is going and what the practical benefits will be, but I can see them when I read the papers in the 70s from a Ted Nelson or something like that. I can see where this is going.
Yeah, and it's interesting. The way I finally understood why immutability is so important is because it basically eliminates the axis of time from programming. That's what it's basically doing. Time becomes a parameter in your data. It's basically that version at that time, and then another version another time, and so on. And this metaphor can actually, it's probably more intuitive that we realize, because indeed when you change a phone, you don't get a new phone, but every second it passes, your phone battery gets, it's not as good, and your phone kind of decays. So basically, there's a new state for your phone every time, every second, every minute. And this is something that actually Alan Kay has described really well in how to eliminate time from programming in this way. It's really useful, and this is something that's been done beyond blockchain and these things. It's also event sourcing, which I'm not sure you are familiar with.
Yeah, GitHub is a revolution, or Git is a revolution because of this, because of immutability.
Git, Git is one way of.
If you're talking about source, right? Source code?
No, event sourcing.
Ah, okay.
Event sourcing is an architectural paradigm where you, instead of storing data, you store the events that happened on data. And it's kind of like Git. So you basically store the events, and from time to time you can apply them to the initial state. But it's like moving immutability at the architectural level. So, and I could imagine this working extremely well if you had specialized hardware for it. It might work even better than, because now we are kind of, there are some databases that work with this paradigm, event sourcing. I don't remember the specific name, but basically they store the events and the initial state, and then you can work around with them. But that's the current solution. If this were in hardware, it's already probably much easier.
And when you query a system like that, what's your default? Like your default's the most recent state, or because what actually exists, right, is the original data, and then we have the changes. So if there's 20 steps to the most recent change on one part of the data, and then we have other properties that are also changing, getting to the most recent state could be very time consuming if we're not storing the changes. So a query, how does a query work then?
I think it can also store kind of the current version.
Okay.
When you need to carry it.
Like memoization then.
Memoization. Yeah. So there are all kinds of optimizations that they do, and that's why you need a separate database engine for this. Because it works in a different way. But this is the closest we've gotten to immutability in architecture right now.
Yeah, and there's also, of course, Datomic, which is the closure immutable database, right? And I believe that still works on trees the same way that Clojure does. But I'm talking actually a little bit out of my level now, because I've only worked with Datomic once professionally, and I hardly even touched it. I'm not good at writing Datomic queries or anything like that, and I've hardly worked with even the concepts, so I don't want to get too deep into that.
Okay. You mentioned a few courses that you did in university that you taught, like ethics and computers in society, and I find these topics fascinating, and I have no idea what would be in such a course. Could you share a few things?
Sure. I mean, I love teaching these courses, and I'd love to do it again. I mean, I'm in a kind of a transition period because I last taught in the United States, and now I'm in Europe. So we'll see. But in terms of the curriculum that I developed with some colleagues at Stevens, for example, the way it worked was we basically had sort of maybe like a 5-week introduction. I'll go into a couple details here, but a 5-week sort of introduction on some of the sort of like hitting the present day concepts, maybe 4 weeks. Then we had like a 4-week sort of history overview. And then we sort of the last 4 weeks, so I'm around 12 weeks, maybe 16 weeks. I don't remember what the semesters were there. We would talk about contemporary, we sort of speculate into the future based on what's happened in the past and based on sort of some ethical paradigms that we've explored. And then I would also, given the time, I'd have 1 or 2 weeks at the very end on computers and art, so specifically looking at artworks made since around the Turing machine that are related to computability as a concept. So not every artwork is necessarily made with computers, but computability is a concept being a change in how artists in the West actually operated, right? It changed how artists thought about the world. Computability, even artists that had never used a computer in 1940 or 1950 were thinking about aesthetics in different ways. So, and of course, the front end of the class, it was important to talk about some ethical frameworks and some ways to think about these problems. And one of the things that I would change and do better next time is it's very important to me to have students understand how I came to whatever the conclusions, like why did I choose to talk about this topic or that topic? Like the thinking that I came to these places, like, because that's where you start to teach like how to think about problems instead of here are the facts. How to, that's really what I could improve teaching that class, because these students are going to encounter problems that we can't imagine today, and we need them to be prepared for that. I don't think anybody is, but we want to do the best we can with these tremendous moral issues that we're going to be confronting in the next 20 or 30 years. So for example, one of the the first paper we read every semester I taught it was Langston Winter's Do Artifacts Have Ethics? I think it was. It's been a couple years since I taught this. Langston Winter's famous paper, and he published in 1980. And what he was talking about was like he was trying to get rid of this concept that or challenge the concept, I should say, that technology is neutral. It just depends on what we do with it, right? And his point is technology is not necessarily neutral. For example, nuclear power. If you, assuming that you want to avoid a nuclear holocaust, let's just start with that assumption, right? Certain political infrastructure has to exist to maintain an arsenal and power plants, right? Once you build them, the political structures that built them are perpetuated off the building of that infrastructure. And if you went to and you decided as a civilization, or as a society, I should say, that okay, it's time for anarchy. This is what you really not that anarchy is necessarily plausible, but it's not even something you can entertain because it's baked into nuclear power that you have to maintain it a certain way. So the politics are tied to this. And so there are baked in sort of politics, and then there are incidental politics, because of, say, automation. There are these incidental politics, but that are deeply rooted in the technology itself, right? So these artifacts having political positions as they're constructed. So that then gets us into a place when we look at computers not as like neutral objects or objects that are that can bring us a techno-utopic future, like something where the future will be so much brighter once the machines solve whatever problem, you want to solve climate change. Or in the 1980s, for example, the techno-utopian sort of movement with Stuart Brand was all about how the personal computer was going to liberate us because, of course, this is an information machine and we'll all have access to information finally, and there won't be the same hierarchies that there used to be. There's a lot to be debated about how this PC thing played out and how we're abandoning the principles of the PC as we move things to the cloud, as we centralize power again, and as we take our data and give it away in a way that in the PC era would have been unimaginable, right? But the underlying sort of concept here, the underlying issue, with the techno-utopians is the idea that the PC itself was a tool of individual liberation. And, it's hard for me to say that computers have brought us, for example, you and I, because of this technology, can have an amazing conversation from Bucharest. It doesn't matter that I'm in Turin, Italy. I could have been in New York, and Mosaic can start an online classroom. These are amazing achievements that are sort of, in one level, decentralizing forces, decentralizing education in very profound ways. Another side of the coin, though, for example, wealth has just continued to centralize increasingly over the last 20 or 30 years, and the computer seems to have no effect on the democratization of access to goods and services and wealth, and it seems to be increasingly tightened and centralized. Even during the PC era, it increasingly got that way. So looking at these tools specifically, and hopefully with my students, as a way to sort of combat the Kool-Aid if and when they do get a job at Google or at Amazon or at Apple, and to think critically as they do these jobs, because they're on the front lines of what these companies are going to be.
Yeah. Yes, that is I can see why it's a very interesting topic to discuss, to debate, to think about from an early age as computer
Well, it'd be
scientist,
great if it was
computer
even
professional.
earlier. Yeah, I mean,
it would be great. Yeah.
I think in the United States, for example, the lack of a media literacy class is a real shame. We don't have this sort of pedagogical concern around real contemporary issues like computational literacy or media literacy or these things that really affect people and will continue to affect people. Yeah, I just wanted to say one thing about the great work that I think your company is doing, Alex, like what you're doing there in Bucharest, organizing conferences and putting together sort of educational opportunities online. One of the things that I've been really impressed with since knowing you, knowing everybody there, is the fact that I feel like you're really putting together the infrastructure to get people talking and having good conversations, not just about, like, for example, in your case, a C++ conference or something like that, that was very technically specific, but even in those sorts of areas, even in the conference domain, you're also sort of questioning, is this the best way to run a conference? And so there are people there that actually just want to talk about how to run a conference. Do we do an unconference? And there's always experimentation with running a conference or talking about these larger sociological sort of concepts related to our work, or of course, drilling down on the technical stuff. So, yeah, thanks for including me in this community, because I've actually kept some friends over the years that I've met at iTakeOn conference and continue to have good conversations along the way.
That's great to hear. We worked very hard on organizing iTakeOn conference and figuring out how to bring different people together, and it's always good to hear that something good got out of it.
Yeah, absolutely. Okay.
Thank you.
Thank you.
Yeah. Okay, so it's been a very interesting discussion, and I think we could continue for hours, but it's probably time to stop.
Pour me a beer and I'll stay around for as long as you want.
Yeah, I think we'll probably do this again soon.
Great.
If we think of new topics,
sure.
We can debate. So thank you, David. This was very, very interesting. And to everybody who is watching this, thank you all for watching. I hope you find these conversations very interesting. I definitely enjoyed discussing all these ideas, not only about programming, but around the world of programming as well. And until next time, don't forget to think, design, and work smart. Thank you.
Thank you.
Coming next.
The panelists were going, Fred Brooks talks, and that was cool. I got to talk to a couple of my heroes, Fred Brooks and Dave Parnas. And Dave Parnas, they would talk a little bit. So there was the typical panel where 5-minute kind of introduction. And then it came time for Martin Fowler to talk. And Martin Fowler all of a sudden fell down underneath the table, and he's kind of shaking. And all of a sudden he comes up and he has a wolf mask on. And it's it looks awesome as anything. It's a realistic looking wolf. And he says, "Oh, well, nobody invited me to this party. I decided to come and tell you why that there's no silver bullet still, and there's not, that even objects is not going to save you or whatever. There's still stuff going on. There is no real silver bullet." And he played in form all the way through, kept that mask on all the way through.